everyone, let's take a look at the density of copper lab. One thing I want to point out is to make sure that you guys are reading this background information. There's a lot of important information in there, and it can also help with the lab. So let's go through and address these questions. What is density? Well, as I was saying, if we read through the background, we can see right here that density is defined as the ratio of a material's mass to its volume. That's a little bit wordy. Another way we can think of density is compactness. So, how tight are those particles held to one another? If it's really tight, we would consider it dense. If not, we would not consider it dense. Let's look at the data trend. So, unfortunately, the data trend is not here in the background, but if we look into this and we look it up, what we can see is we can see that a trend is a general direction or, a pattern that the data is following. So a good example of this is if we look at height. We can collect data from the day that we're born until today, and we can see the general direction that that height goes is up. So the pattern or the data trend would be our height increases as our age increases. That's what we're talking about when we look at a data trend. So now that we've got the pre-lab out of the way, let's work through the actual procedure. Typically we would do this in class, however, we're obviously not in class, so I have provided a video of the procedure that talks about safety precautions, that talks about materials, and most importantly, talks about how we're getting this data. Okay, so be sure to watch that. If you have not, go ahead and watch that now. Okay, let's look at our data. Well, again, we look to the lab and we see some really important pieces of information. We see that our formula is D equals M over V. Well, what does that M stand for? That M stands for mass. So here we see mass. This whole column is going to represent our M variable. Well, what about the V? Well, that V stands for volume, and here we can see that we have volume, and this whole column is going to be our V variable. Now what we have to do is plug our data in. So 8.7 is our mass, 1 is our volume, so 8.7 divided by 1, and when we carry that math out, that's going to give us 8.7 grams per milliliter. That's our density, and it's important that we require a unit of mass per volume. This particular instance, grams per milliliter. Let's move on to sample 2. We have a new mass and a new volume. So 23.1 divided by 2.6. Well, I'm going to have to use the handy calculator for that one. So I type in 23.1 divided by 2.6, and I get 8.88. We can round that to 8.9, and again, that's grams per milliliter. Let's continue this. 25.9 divided by 3.1. I'll just write that off to the side so we can see the math that I'm doing. But again, I'm going to plug that into my calculator, and I'm going to get 8.35. We can round that up to 8.4, and again, grams per milliliter. So if we can look, we can see our trend is pretty much staying the same. 8.7, 8.9, 8.4. We're pretty close. Let's take a look at sample 4 and see if we get the same density or something similar. So again, I'll write out our 42.1 divided by 4.8. I'll plug it in my calculator, and I get 8.77. I can round that to 8.8, and again, that's grams per milliliter. So if we were to look at a trend in our data, we would see that the pattern is staying the same. It's pretty close, okay? So let's take a look at what this looks like on a graph. So we've already graphed this out for you. What we need to do is just go through these questions and make sure we know how to interpret the graph. So when we look at number 1, it's looking for a volume, so right away we know our answer should be in milliliters. It wants to know the volume of water displaced by 15 grams of copper. Well, let's take a look at where we see water displacement. Here, this tells us the volume of water that's displaced, and here tells us our mass. Well, we know our mass is 15 grams, so we're going to find 15, and we are going to follow that line up to our line, okay? And now we are carefully going to move this over, and we are going to see that we are somewhere between 1 and 2, closer to 2. So I would estimate this to be around 1.8 milliliters, okay? As long as it's above 1.5 and below 2.0, you should be good. Let's do the same thing, but in an opposite direction. So here, what we're looking at is a volume of water and trying to determine the mass. So we know that we're measuring grams, and we're starting with milliliters. So let's come up to here at the 4, and let's follow this all the way over. Sorry, that's a terrible line. Until where the line meets. And we are then going to follow that down. And we are going to see that that is approximately 35 grams. Okay? So, we can hopefully pick out a point given another point in a graph. Let's look at the mass as we move left to right. Here we're talking about a trend. So what do we see happening to the mass? Well, let's first get rid of some of this stuff here so we can see this better. But if we look, here we have a mass of about 8. Here we have a mass of about 23, about 26, about 40, 41, 42. So what was happening to those numbers? Well, they were most certainly increasing. Okay, so we would say that our mass increased. Let's look at number 4. Again, let's get some of this stuff out of the way so we can see this a little bit better. But when we look at number 4, we're looking for the mass and the volume at point A. Well, when we look for the mass and the volume, this is just an ordered pair. So let's find point A, and let's find our x. Well, point A is right here, and it looks like we're at 15 grams. Let's do the same thing for volume. So here we're going to have to follow this line carefully over, and we can see again that's somewhere between 0.1 and 0.2. I'm going to say it's about 1.7 milliliters. Okay? Now, how do I get the density from that information? Well, again, if we remember, our formula is D equals M over V. Now we can plug our numbers in. So our M is our mass, that's 15 grams. Our V is our volume, that's 1.7 grams. And let's 1.7 milliliters. Now let's go ahead and plug that into our calculator. 15 divided by 1.7, and we get 8.8 grams per milliliter. And if we notice, this number looks pretty similar to all of these numbers. That's going to be an important piece to kind of keep in the back of our mind. Okay? So what is the density at point B? Well, again, just like for point A, we had to first find our mass and our volume. So let's go to B. Let's come down, and we can see our mass is about 35 grams. Let's carefully follow this over, and we can see that our volume is about 4 milliliters. And now we can do our math. So we said, again, 35 grams, 4 milliliters, and let's plug in our numbers. So 35 divided by 4 gives us 8.75, and we can go ahead and round that up to 8.8 grams per milliliter. So how can we compare these two? Well, we can see that they're the same. The density has not changed. We can add a whole bunch of information here, and this is kind of open-ended. So if you do have questions on this, of course, make sure that you get those asked and answered. Hopefully this has been helpful. As always, if you have any questions, please do not hesitate to reach out, and I will get an answer to you as quickly as possible. Thank you.